Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
My contributions to computational mathematics are these. I mathematically and experimentally discovered how to compute and solve initial boundary value problems that were previously impossible to solve. I discovered how to execute excruciatingly detailed petroleum reservoir simulations. Such extreme scale simulations in turn enable petroleum engineers to discover and recover otherwise undiscoverable and unrecoverable oil and gas. I discovered how to foresee otherwise unforeseeable global warming, and how to do so by executing extreme scale general circulation models, and how to do so by executing them at a never before seen resolution and executing them across my ensemble of processors that is a new internet and that is a new supercomputer de facto, but that is not a computer per se. The modern parallel processing supercomputer is not the sequential processing computer of the old sense and of the 1980s and earlier. Each modern parallel processing supercomputer is defined by the configuration of the ensemble of processors that outlined it. I invented a new configuration of processors that defined a never before seen supercomputer that I named the cosmic supercomputer, and that outlined a never before seen internet that I described as a hyperbole global network of processors that is described by the book History of the Internet and described as a small copy of the internet and described as the contribution of Philip Emeagwali to the invention of the internet. My knowledge and experience with the supercomputer began on June 20, 1974 at the Computer Center at 1800 Southwest Campus Way, Corvallis, Oregon, United States. The computer has changed since it was invented in 1946 and invented as automatic programmable and processing sequentially. But the way we define the computer has not changed. In 1946 and now, we still define the computer as the tool that enables a person to execute the fastest computations. Back in 1974, the prevailing dogma in supercomputing was that parallel processing will forever remain a huge waste of everybody's time. The paradigm shift from serial computing to parallel computing occurred in 1989. There were three reasons I couldn't make my 1989 experimental discovery of parallel processing in 1974. First, I didn't have in 1974 the intellectual maturity across computational physics, across abstract calculus, across large-scale algebra, across extreme-scale computation, and across message-passing communication. I acquired that intellectual maturity during the next 16 years onward of March 25, 1974 of full-time study and supercomputer research. The second reason I couldn't discover parallel processing in 1974 was that I didn't have a global network of 64 binary thousand processors that I needed to use to reconfirm my theoretical discovery of parallel processing. I can only experimentally reconfirm my theoretical discovery across those 65,536 processors. The third reason I couldn't discover parallel processing in 1974 was that the fields of calculus, computing, and email communication grew enough to enable me to do my experiments and do it across a small copy of the internet that's a global network of 64 binary thousand processors. But more importantly, my original inspiration was to discover a new technology, namely a small copy of the internet that emulates a new supercomputer. That new technology, that is a new supercomputer, is a new instrument of extreme scale computational physics that's indispensable in the quest for oil and gas. That's indispensable in foreseeing otherwise unforeseeable global warming. And that's indispensable in vast and sundry problems in extreme scale computational physics. That the fastest supercomputer costs as much as the budget of a small nation is a measure of its wide applications across the sciences and society. Parallel processing is the technological engine that powers both the slowest computer and the fastest supercomputer. My discovery of practical parallel processing earned me the highest prize in supercomputing and made the news headlines in 1989 and was newsworthy because it opened up the new fields of seeking parallel solutions of initial boundary value problems that occurs from mathematics to medicine, from biology to chemistry, and from astronomy to physics. When you are inventing something, that thing is yours. When you've invented that thing, you give that thing to posterity, and that thing is no longer yours. For instance, my experimental discovery of the massively parallel processing supercomputer was the cover story of technical publications such as the May 1990 issue of the Siam News of the Society of Industrial and Applied Mathematics. The Siam News is the flagship bi-monthly news journal of record of the research mathematics community that is 500,000 mathematicians strong.
insightful and brilliant lecture.